This is lesson 6.5. Today we're going to talk about modeling with linear functions. Modeling is another way we talk about word problems. So we've been working a lot so far with lines and linear equations and functions, but we haven't worked very much with thinking about real-life situations. So your aim today is that I can use the form of y equals mx plus b to model real-world linear situations. When we use equations to model real-world phenomena, we often look to linear models first because they are the easiest to use and understand. We can now use our skills, which is what we've been working on so far, from the last few lessons to model real-world linear phenomena. Don't ever forget these two facts about linear models. All linear models in the form of y equals mx plus b have two parameters, the slope m and the y-intercept b. The first part is that the slope m, tells us how fast the output is changing relative to the input. So it talks about speed, rate, the amount something is changing. The y-intercept, on the other hand, tells us how much we start with. This is really important. The y-intercept b always tells us how much we start with at x equals 0. So with those things kept in mind, let's take a look at exercise 1. Exercise 1. Janine has $450 in her savings account at the beginning of the year. So right there, I see at the beginning of the year, this right here is the start of something. So this 450, that is my b or my y-intercept. Keep going. She places money in the account at a rate of $5 per week. So there's a rate, so that must be my slope because of the word rate. Okay, so these are key words that you look for when you see a word problem. Rate, start, beginning, to figure out what your slope and your y-intercept is. We want to model the amount of money she has in savings as a function of the number of weeks she's been saving. So part A, fill out the table below for some of the number of weeks. Show the calculations that result in your answer. So at 0 weeks, this is the start of her saving. At the very start of her saving, she has $450 in her savings account. After 1 week, she has the $450 she started with, plus she's going to save $5. So 450 plus 5 is $455. Okay? After 5 weeks, she has that 450 plus how much she's been saving per week. So she saves, technically this would be like 5 times 1. She's saving $5 per week at 5 weeks, so this is going to be 450 plus 25, which gives you $475. And at 10 weeks, she starts with 450, but now she's saved for 10. So you've got to multiply the rate by 10. So I get 450 plus 50 to give you $500. So we're just figuring out how much she's saving after so much time. Okay. Letter B, use the information in the given or in the table to write an equation. So this wants us to write an equation. Well, I know my equation has to be in this form, y equals mx plus b, because the problem says that it's linear. So I'm going to take my slope, which I found out from here. Oops, sorry, that's in purple. My slope is the same thing as my rate, which is 5. And my y-intercept is b, which is 450. And now I just have to plug in the y equals 5x plus 450, and I have my equation. Okay, now I've made one mistake in that this problem wants me to use the letters S and the letters W. So instead of leaving my answer as y equals 5x plus 40, I'm going to change my answer to S equals 5w plus 450. The W stands for weeks, and she's saving $5 per week, and then you'll get your total savings with S. So this is what the problem is asking for with the correct variables. Okay? Letter C, if Janine saves for exactly 1 year, what is the range in her savings over the year? Show how you arrived at your answer. Now, unfortunately, this problem is talking about weeks, so we need to turn this 1 year into weeks. Now, the Common Core expects you to know this kind of information. It expects you to know how many weeks are in a year, expects you to know how many feet are in a yard, things like this. So there are actually 52 weeks in 1 year. So now that I know that there's 52 weeks in a year, I'm going to just plug in 52 weeks into my formula, into my equation. So I'm going to have S equals 5 times 52, because I'm plugging in for W up here, plus 450. This is going to give me S equals 260 plus 450, so her total savings will be 710. Okay? All right, letter D. Oh, wait, I didn't actually answer the question. What is the range in her savings over the year? So this question doesn't ask how much she saves, it'll ask how much her total range is. So the range, remember, is this. So here's this is my domain, because it's my inputs. This is my range. So what is my very lowest number of savings to my very highest number of savings? Well, my lowest number is 450. That's the minimum amount she has in her savings. And then the highest amount she's going to save, because she's looking for the 1 year, is this 710. So her range of savings is from 450 to 710. That's how much she'll have saved from the lowest in the year to the highest in the year. She'll have started with 450 and saved up to 710. Okay? So that is my range. Letter D. Why would it not make sense to evaluate S of 6.5? So why would it not make sense to evaluate S of 6.5? In other words, what types of numbers belong in the domain? So we're thinking about this 6.5. Now 6.5 it's S of 6.5, so the 6.5 stands for weeks. Okay? Why would it not make sense to think about 6.5 weeks? She's saving $5 per whole week. So it does not make sense to evaluate the function as a fraction of a week. 6.5 is saying that I'm in between 6 weeks and 7 weeks. So there's no part of this rate that says she's saving something per half a week. This rate is only the per 1 week. So you can't really judge how much she's saving as a fraction or a decimal. It doesn't make any sense to do that. So the domain, in reality, your domain would actually be, your set of whole numbers. 1, 2, 3, 4, and so forth. Right? It's going to be a set of whole numbers. You cannot have decimals in your domain in this problem because it doesn't make any sense. And that's something you have to think about logically. When problems like this ask you about sense making, you have to think about, okay, if I were this girl in real life saving, why doesn't this make sense? There's no math I did in this problem in letter D. I didn't calculate anything to come up with my answer. I just used logic and thinking that you can't save a half a week in this problem. It doesn't say to do that. Okay? Letter E, use 2 points from the table to verify the rate of change is actually 5. So this is one of those check your work kinds of things, and it wants you to pick 2 points from the table to check the rate of change to be 5. So let's do that. Let's pick 2 points. I'm going to pick the point 5, 475. So this point and this point that I'm circling up here. And let's just pick the next one after that, and 10, 500. So I'm picking these 2 points up here to find the rate of change. And now to find that, we just use that formula we've been working with so long. And I'm going to subtract the y's, so 500 minus 475 over 10 minus 5, and I get on the top 25, and on the bottom I get 5, and 25 divided by 5 is actually 5, so I have indeed verified that my work is correct with the rate. How do the units now show up in the calculation? Well, it's $5, so put your dollar sign, per week. Oops, not per week. Okay, so these are my units of my rate, $5 per week. Now this was just one big problem, one situation with a lot of little mini questions that went with it. Okay, let's take a look at exercise 2. So here's another new situation we're going to look at. Sometimes the information we have about a linear relationship does not include the starting value. So in the previous problem, we had the starting value as 450, but that's not always the case. Sometimes we have to figure out our starting value. So let's read the situation. Exercise 2, Kirk is driving along a long road at a constant speed. So when I see this word constant, that's a big clue that I am working with something linear, that I am working with a y equals mx plus b. So I underline that and say to myself, I know that I need to think about a linear relationship here. That's a clue. He is driving directly towards Denver. Denver is a city in Colorado. He knows that after 2 hours of driving, he is 272 miles from Denver. After 3.5 hours, he's 176 miles from Denver. Okay, so we're given some information. Now how are we going to use that information to help us reach our goals? So letter A says, summarize the information given in the problem as 2 ordered pairs. As 2 ordered pairs, where the number of hours h is the input and the distance from Denver d is the output. So it wants us to order the pair like this. Instead of x comma y, we're using h and d. So if I want to think about my first piece of information, the first piece of information says he is he is 2 hours after driving 272 miles. So after 2 hours, he's 272 miles away. So 2 hours, he's still 272 miles away. So this is my h and this is my d. So I can write that as 2, 272 as one coordinate. The second one is after 3.5 hours, he's 176 miles away. So I'm going to turn that 3.5 into 3.5 as a decimal. So after 3.5 hours, he's 176 miles away, and that would be the coordinate 3.5, 176. So now I've got 2 coordinates to use to try and figure out some information. All right? So letter B, calculate the change in distance, because remember that's how we read this little triangle symbol, the change in distance over change in hours equals d of 3.5 minus d of 2 over 3.5 minus 2. Where are they getting that 3.5 and 2? From right here, from those coordinates we just found out. So they're using that rate of change formula that we've done so many times before. They're just helping us out and writing it out. So let's finish that. Change of distance over the change of time. D of 3.5 is 176. And d of 2 is 272. So you're really just subtracting the y's, and then 3.5 minus 2. Now we simplify. 176 minus 272 is negative 96. Be careful of your signs. And 3.5 minus 2 is 1.5. When you put this in your calculator, you're going to get negative 64. This says include units. Well, it would be miles per hour. For this. In fact, let's just simplify that to mph. It's negative 64 miles per hour. Now letter C says you should have found out that the rate of change is negative. Right? The rate of change is negative. Why is it? Explain what's physically happening to result in this negative rate of change. Well, think about what Kirk is doing. He is driving directly towards Denver. And D stands for the distance from Denver. So the rate's negative because Kirk's distance is decreasing as he gets closer to Denver. So we know that in a linear function, or in most functions, a negative slope means decreasing. And a positive slope means he's increasing. If he were getting farther away from Denver, his distance would be increasing, but he's getting closer to Denver, so his distance is decreasing. So that is why we have that negative symbol right there. Okay? Letter D, assuming the relationship is linear, which we already assumed it was. I assumed it from the beginning because I underlined that word constant, and that's what this is saying here. Constant speed means linear. Write an equation for the distance d as a linear function of the number of hours. Now the problem with this is we have our rate. We have a rate of negative 64. So I know that my m equals negative 64. I know, but I don't know what b is. That's my big problem here, is that I have no idea what b is going to be. So I have to figure that out. I have to figure out what b is. So like in previous problems before, we've had to use 2 points to help us do the math here. So I'm going to pick 1 point from the beginning. So I'm going to pick the first one, the 2, 272. And the 2 is my h, and then remember the 272 is my d. So now what I can do is I can plug in to y equals mx plus b, and I can find what my missing b value is. So instead of a y, I'm going to plug in a 272. Instead of an x, I'm going to plug in a 2. Instead of m, I'm going to plug in that negative 64. And then I'm going to solve for my missing b. So there's an equal sign. Oops, sorry. That should be plus b. Now I can solve this here. So I'm going to have 272 equals negative 64 times 2 is negative 128. Now I add that to both sides to get b by itself. And I get 400 equals b. Now that I know my slope and my y-intercept, I can write my equation. Remember the variables you're using. You're using h and d. So you're going to have d equals negative 64h. I'm going to negative 64 from this because that's my slope. From here, there's my slope, plus 400 because that's my b value. So I have my equation of negative 64h plus 400. Okay. Finally, last two questions. Letter E, how far did Kirk start from Denver? So this question is asking you for, distance. How far? So it wants you to know what is the distance when he started. When he started, the time was 0. So this is a very fancy way of saying find d when h equals 0. And your keywords here are how far and start. Do you see how I underlined those for myself? Because I'm trying to figure out what this question's asking me. Because on the Regents, I'm not going to be there to tell you guys what the question's asking you. You have to use these keywords to try and translate what the question wants you to do. And then this one wants you to find distance when h equals 0. So I'm going to use my equation, my new one that I just made up. D equals negative 64h plus 400. But now, instead of h being a variable, I'm going to plug in 0. So now I solve. Negative 64 times 0 is 0. 0 plus 400 is 400. So the answer to this problem is that he was 400 miles away when he started. That's your answer to this problem. Okay. Now F says, after how many hours will Kirk arrive in Denver? This is just the opposite. After how many hours? So it wants you to find out what h is. How many hours? Find out what h is given when he arrives in Denver, which means that your distance here would be 0 because he's in Denver, right? He's not anywhere away from Denver. He's in Denver, so his distance is 0. So this question is just saying the opposite. Find h when d equals 0. So we're going to use our formula again. D equals negative 64h plus 400, but now I'm going to make d equal to 0. and try and solve this equation for h. This is a little bit harder. I've got to do a little more steps. I have to subtract the 400 first. 0 minus 400 is negative 400. Then divide both sides by negative 64 to get h by itself because that's what I want. And I find out when I use my calculator that I get 6.25. So the answer is after 6.25 hours, Kirk will arrive in Denver. So a lot of this lesson is about looking at the things I'm underlining. When I'm look at every question you see me doing, I'm underlining something. I'm looking at the word problem and I'm underlining these big clues that tell me what math I need to do. So when you guys do your work, you should always be underlining, always be looking for those keywords, right? And then we're going to talk about using the problem-solving template a lot more in class and how that problem-solving template can really help you narrow down what you need to do for these problems. Okay? We have one last question. It's a multiple choice question about Amanda. So let's take a look. Amanda is walking away from a light pole at a rate of 4 feet per second. If she starts at a distance of 6 feet from the light pole, which of the following gives her distance from the light pole after walking for t seconds? So we've got to remember something really important. One is that your b value is your start. So in here, where does it say she starts? She starts at a distance of 6 feet. So boom, right away, I know that my y-intercept is 6. Now the cool part about this problem is that I know that in y equals mx plus b form, where does b go? B goes right here at 6, correct? Do you see, what answer choice do you see ending in 6? Only answer choice number 1. The rest of these don't end in 6, so they can't be the answer. That's a test-taking strategy right there. This problem does give me this extra piece of information. It does say 4 feet per second, sure. So I know that m is 4. So if I really wanted to do this the whole right way, I could say, oops, my pen is not really working. I could say, okay, y equals 4x plus 6, and that matches answer choice number 1. Well, or, d equals 4t plus 6. But in this problem, I didn't need the 4, because no other answer choice had a 6 as a y-intercept, and I know from this lesson that my starting point is my y-intercept. I know that. Starts at 6. That has to go right here. Okay? So this is kind of using deductive reasoning, finding clues in your problems to help you answer questions. Okay? Work on your fluency. Practice with me, please, in class, or Ms. Sammer with Ms. Vasquez before you go on to mastery. Or, excuse me, your next lesson is 6.6, and then you can do mastery. Okay? Good luck.